Okay. So here the same type of figure I have drawn as I have explained very well last class. Here a small figure is next. So here we have to discuss about angular momentum. So you have to consider a particle here, particle at k, particle of mass m at k. Consider a particle of mass m at k, and this is axis three mutually perpendicular axis x, y, and z axis, and here its position vector is denoted by the letter vector r. So consider a particle at k. Its position vector is vector r. Then here the body experiences momentum. For example, it is moving in this direction. Particle is actually we are studying rotational motion. So we exerted a force. Because of that, it is moving. So the direction of momentum is shown here like this. This is this particle's momentum is shown with this vector p. That is the linear momentum vector. And then so we know the direction of r. This is the direction of r, position vector, and this is the direction of p, momentum, linear momentum direction. And what is angular momentum? That is what we have to find out. And so here it is actually angular momentum is the cross product of r and p. So p means mv, moment, m into v is momentum. So as we have seen in the definition of torque is the moment of force. But here linear momentum is moment of momentum. So the equation, what will be the equation for momentum? Angular momentum L equal to r cross p, cross product. We have to find out cross product of r and p. What is r and p cross product? Rp sin theta. It is a vector quantity, and as a vector, how will you express it? Vector r cross p. What is the direction of L? Perpendicular to both r and p. And what's the magnitude of L? L equal to Rp sin theta. So depending upon this angle, the angle between r and p, angular momentum value will be changing. So it can be written in different form, L equal to r into p perpendicular, or r perpendicular into p. P perpendicular means what? Perpendicular component of momentum. P perpendicular is p sin theta. It is the component of p in a direction perpendicular to r. So let us see that. What is the component of p in a direction perpendicular to r? So here this is the direction of momentum, and we know this is the angle theta. If this angle is theta, this angle also will be theta. And a component of p, we are taking the component of p two direction. That means when we take the rectangular component of p, we have two components. One component along this direction, that is p cos theta, and the other component perpendicular to that will be p sin theta. So along the direction of r, p cos theta, perpendicular to the direction of r, it is p sin theta. And this p cos theta have no influence in producing the angular momentum of the body. Only p sin theta has the influence because it is rp sin theta. Cos component has no influence on it. So rp sin theta. So which component we need to find the angular momentum? We need p sin theta. So that is why it can be written as r into p perpendicular. That is one method. Or you can write p into r perpendicular. Both way you can express the angular momentum, magnitude of angular momentum is equal to rp sin theta, and direction of angular momentum is a vector quantity. Direction of angular momentum is perpendicular to both r and p, and it is given by right-handed screw rule or right-handed thumb rule. Both can be used. So when is the angular momentum zero? From the equation you can tell angular momentum equal to rp sin theta. It is moment of momentum. What is moment of force? Moment of force is torque. What is moment of momentum? It is angular momentum. And from this equation, L equal to RP sin theta, we can tell values of L for different positions of angle, different values of angle, we can tell the value. For example, when is it maximum? Angular momentum, when is it maximum? Then alok, when is that angular momentum maximum? Alok, from the equation tell. Alok is there? Alok, Akshaya is there? Akshaya?
Yes, ma'am.
When is the angular momentum maximum? From the equation tell. L equal to RP sin theta. When is it maximum? When this value take its maximum value? For which value of sine it will take maximum? For which angle sine gives its maximum value? Do you know that?
90 degree.
90 degree, 90 degree. So, theta is the angle between R and P. So, when R and P are perpendicular to each other, when R and P are perpendicular, that means theta is 90, angular momentum will be maximum. Just like we have seen torque, when we close the door, when we apply a force perpendicular on the handle, if we apply a force perpendicular, then only the maximum torque is produced, just like that. When we apply, when this angle between R and P is perpendicular, then angular momentum will be maximum. When is it taking minimum value? When angular momentum is minimum, that is 0. For which angle? Gramiatal. For which angle? Which value of theta? When is it minimum?
180 degree.
Sine 180. Or what about 0? 0. What is sine 0? Sine 0? Don't know. Sine 91. What is the value of sine 0? Sine 0 also 0. Okay. 180 also 0. So here when 0 or 180, that means when they are parallel or anti-parallel. Parallel or anti-parallel. Then angular momentum is minimum. When is angular momentum? Other cases for angular momentum 0. What are the other cases for momentum L equal to 0? Either R equal to 0. That means R means distance from the. I'll show you the figure. What is R? See the figure. What is R? R is the disposition vector. That means the distance from origin to that point. Origin. This is about this axis, the body is rotating. Z axis. Suppose this is Z axis. About this axis, the body is rotating. So this distance, this is the distance from origin to that point. So this R. When R is 0, that means if the point is here, if the point is here at the origin or along this line, the point is somewhere here, angular momentum will be 0 because R is 0. That's true. And if P is 0, if the body is not moving, P will be 0, no momentum. No momentum. So in that case also, angular momentum is 0. So when, for which all cases angular momentum becomes 0? When R is 0, angular momentum is 0. Then another case, when P is 0, linear momentum is 0, not moving. Then angular momentum is 0. One more case, when theta is 0 or 180, that means angle between R and P, that is 0. That means along this line itself. If P is acting along the same line or P is acting along opposite to this direction, both cases and all these three cases, angular momentum will be 0. Okay. It is similar to the explanation of torque. Next. Relation connecting torque and angular. Now we have studied torque. Torque is moment of force. Moment of force R cross F. Angular momentum is L, denoted with the letter L. It is equal to R cross P. So we have to find the relation between the. What is linear momentum and force? What is the relation? Linear momentum and force. Pavitra, what is the relation between linear momentum and force? Linear momentum, according to Newton's second law. Second law is deleted, but I think you are knowing what is the relation between linear and force. Pavitra? Reflecting. We'll ask another one. Tamanna Shaju. Tamanna Shaju. Tamanna Shaju. Tamanna Shaju is there. Tamanna Billuraj. Adilakshmi, can you tell relation between linear momentum and force? That is the problem. Second law is deleted. Anyone? But here we have to apply that. Anyone? Rate of change of
The rate of change of moment of a body is proportional to the applied force.
Yes, very good. Rate of change of momentum is directly proportional to force. That means rate of change of momentum is force. That is Newton's second law. So that is actually the relation between linear momentum and force. Rate of change of momentum is force. So similarly, we have to find out a relation between linear angular momentum and torque. Angular momentum and torque. We have to find the relation. For that, we start with this equation, angular momentum L. We just now got this equation. Vector L equal to vector R cross P. We got this equation. Vector L equal to R cross P. Then you have to differentiate this equation with respect to time. So dl by dt, differentiating with respect to time. So here this is a product. So when you differentiate this one, there is a formula for that. I think we haven't done any of this problem, but you should know the equation. That means when you differentiate a product, the equation will be like this. First into derivative of the second plus second into derivative of the first. That is the formula. So this is a product. If it is u into v, what will you write? U into derivative of p plus v into derivative of u. That is it. Yes. Yes. What happened? Arunisa?
Ma'am, now it's okay.
Okay. So first into derivative of second. That is written here. Vector r into derivative of the second d by dt of p plus second into, what is second? P. Vector p into derivative of the first dr by dt. This is the general formula. We applied the formula. First into derivative of the second plus second into derivative of the first. Like that it is written. Okay. Next step. R cross, what is the rate of change of linear momentum? Just now we told. Just now. That is rate of change of linear dp by dt. That is force. dp by dt. Rate of change of linear momentum. That is force. Vector F plus p into vector p into what is dr by dt. That also we know. What is dr by dt? Adilakshmi, what is dr by dt? Adilakshmi. Krishnasri, what is dr by dt? Krishna Sri. Midun, what is dr by dt? Midun. Adityan is there. Adityan. Abhinav, tell Abhinav. What is dr by dt? Rate of change of position. Vector.
V.
V, correct. Very good. dr by dt is V, velocity vector. So we can write P into V. P into V. And here R cross F is written here, then mv, momentum is m into vector V. Momentum is a vector, mass into velocity vector is momentum vector into V, velocity. So here you can see mv cross V is taken as 0. And in the cross product we have studied its properties. If two vectors are in the same direction, two vectors is mv, momentum, velocity's direction will be in the direction of momentum. Both are in the same direction. What is the angle between them? When both the vectors are in the same direction, what is the angle between them? Megha, what is the angle between them when both vectors are in the same direction? Megha, Devika, tell. Devika,
Yes, ma'am.
what is the angle between mv and v? mv means momentum. V is 0. Very good. 0 is the angle between mv and v. They are parallel, same direction. So angle between them will be 0. So mv cross v, that means mv into v into sine 0. 0. Angle is 0. mv into v into sine 0. Sine 0 is 0. So this mv cross v becomes 0 because they are parallel vectors. Vector product is 0. So mv cross v is written as 0. And r cross f we already studied. It is torque. R cross F is torque. So we got one dl by dt equal to torque. dl by dt equal to torque we got. That is the relation connecting torque and angular momentum. dl by dt, rate of change of angular momentum is torque. What is the similar relation in linear motion? What is the similar relation in linear motion? Rate of change of linear momentum is force. Rate of change of linear momentum is force. Rate of change of angular momentum is torque. Net external torque. So that is written here. Torque is equal to R cross F. We got it is d by dt of R cross P, and we got dl by dt is equal to total external torque acting on the system. Okay, very important relation. So you have to, when you study all these relations, you have to take the comparison with the linear motion. Understand? Rate of change of angular momentum, torque. Rate of change of linear momentum, force. Like that, you have to compare both equations. Next is conservation of angular momentum. Conservation of linear momentum we have studied. What is it? Aisha is there, Aisha? What is conservation of linear momentum? Aisha? Aisha. Aisha is not there. Ridubarna is there, Ridubarna? No? Meherunisa, tell, Meherunisa. What is the rate of change of, what is conservation of linear momentum? Meherunisa? Meherunisa? No answer. Muhammad Adil? Conservation of linear momentum. Laws of motion chapter test paper എടുത്തല്ലേ പഠിച്ചില്ലേ നന 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 Samana Biluraj. Srirag, tell Srirag. What is conservation of linear momentum? Prakash.
Yes, ma'am.
What is conservation of linear momentum? Then we can compare this with that. Conservation of linear momentum.
Yes, ma'am.
What is it? When?
One minute, ma'am. I forgot in the first.
Forgot.
Ma'am, I stated.
Huh? Conservation of linear momentum. And I'll ask you another one. Krishna Prabha, tell.
Ma'am,
Can you tell?
the total moment of an isolated system is conserved.
Yes, that's it. Total momentum of an isolated system is conserved. When isolated system means no external force acting on the system. Isolated system means no external force act on the system. Then total linear momentum of the system is conserved. So just like that, conservation of angular momentum. Angular momentum is rate of change of angular momentum is torque, that we know. dl by dt equal to torque, external torque. And this, if there is no external torque acting on the system, body is rotating. If there is no external torque acting on the system, dl by dt we can write as 0. That means L is angular momentum is constant. That means it will move, rotate around the axis with constant velocity. No acceleration will be there. It will rotate with a uniform velocity. Body will rotate. L is a constant. No external torque act on the system. Angular momentum of the system is conserved. L is equal to constant. If the total external torque acting on a system of particle is 0, then the total angular momentum of the system is conserved. Similar relation. There we study dp by dt equal to f. If f equal to 0, p is constant. Like that we have studied. Similar equation, dl by dt equal to 0. If no external torque act on the system, dl by dt equal to 0. That means derivative of a constant is 0, that we have studied in its equations, derivatives. dl by dt equal to 0. That means L is a constant. Vector L is equal to constant. So this is the statement for conservation of angular momentum in an isolated system. Or if the total external torque acting on the system is 0, then angular momentum of the system is conserved. That is the statement. Next is equilibrium of a rigid body. Equilibrium of a particle we have studied earlier. Do you remember what is meant by equilibrium of a particle? See, what we studied for particle, we are extending it to the system of body, system of particles.
Excuse me, ma'am.
Yes.
Teacher, voice break ആവുന്നുണ്ട്.
പ്രഭയ്ക്ക് മാത്രമാണോ അത് എല്ലാവർക്കും ആണോ?
No, ma'am. The
ഇല്ല.
voice is not breaking.
അതെ കൃഷ്ണപ്രഭ, അത് maybe due to network problem. Okay. I also feel that when you unmute your mic. Okay. You can hear the record. Okay. So here equilibrium of a particle we have studied. Abarna, can you tell what is meant by equilibrium of a particle? We have studied it. Now that we have to extend it to the system of particles. Equilibrium of a particle. Manu, tell. Equilibrium means what?
Teacher, your voice is
Your mic also. I feel that problem here.
Teacher, your voice is
Okay.
breaking.
Okay, I'll ask another one. Okay. Manu Shankar, tell what is equilibrium of a particle? Manu Shankar, total?
Teacher, can you hear me?
Vector.
Teacher,
Yes, tell who is that? Aparna.
teacher, can you hear me?
Yeah, but breaking is there, Aparna. Break.
Teacher, can you hear me?
Now I can hear. Okay. Can you tell what is equilibrium of a particle? Can you tell?
Um,
Manu Shankar told. Do you know? Aparna?
Teacher, can you hear me?
Yes, I can hear. Tell me.
Teacher,
What's the problem?
teacher.
Yes, I can hear.
Okay. Teacher, what did you ask? The voice was completely breaking.
Okay.
Can hear anything.
Equilibrium. I asked the equilibrium of a particle. What is it? Ah,
the net external force is 0.
yes. The vector sum of all the forces equal to 0. Yes,
0.
correct.
Yes, ma'am.
Yes, correct. Vector sum of all the force acting on it is everybody, most of you are having that problem. So here we are studying equilibrium of a rigid body, and we are studying the rotation of the rigid body also. So a rigid body is said to be in mechanical equilibrium if both its linear momentum and angular momentum are not changing with time. Or equivalently, the body has neither linear acceleration nor angular acceleration. I'll explain. If total external force acting on the system is zero, it will be in which equilibrium? Two equilibriums are there. One is translational equilibrium and the other is rotational equilibrium. So, mechanical equilibrium means it has to satisfy both these equilibrium. That means which are the two equilibrium? Translational equilibrium. There is no translatory motion. Net net, there is not acceleration along the direction. Net force equal to 0. That is the condition for translational equilibrium. Net vector sum of all the force acting on the system is equal to 0. That is F1, vector F1 plus vector F2 plus etc. vector Fn equal to sigma I equal to 1 to n Fi equal to 0. This is the condition for translational equilibrium. That is what we have studied in that equilibrium of a particle. But here it has to satisfy that rotational equilibrium also for a complete mechanical equilibrium. For the body to have complete equilibrium, both the equilibrium should be there. Translational equilibrium as well as rotational equilibrium must be there. For otherwise, it will be in partial equilibrium only. Partial. If only one, if the only any of these two satisfy, it will be in partial equilibrium. So here, if both the conditions are satisfied, then only the body will be in complete. That means mechanical equilibrium. So total force acting on the system is 0. That is the condition for translational equilibrium. If total torque acting on the system is 0, we can write vector tau 1 plus vector tau 2 plus etc. vector tau n equal to sigma I equal to 1 to n tau I equal to 0. This is the condition for rotational equilibrium. Total torque equal to 0. So, two conditions are there for the body to have mechanical equilibrium. So, what is mechanical equilibrium? The body will be in translational equilibrium. Also, it will be in rotational equilibrium. So, what is the condition for translational equilibrium? Sigma I equal to 1 to n Fi equal to 0. Total external force acting on the system is 0. What is the condition for rotational equilibrium? Total torque acting on the system is 0. So this is the condition for translational equilibrium and rotational equilibrium. Clear? What is the condition for translational equilibrium?
Teacher,
Yes. Equilibrium net force. Equilibrium of a particle. Teacher എടുത്തില്ലേ ഇപ്പൊ ഒരു ബുക്ക് നമ്മൾ രണ്ടുപേര് പിടിച്ച് വലിക്കുകയാണെന്ന് വിചാരിക്കും ഒരു ഓപ്പോസിറ്റ് സൈഡിൽ ഞാനൊരു സൈഡിലേക്ക് വലിക്കുന്നു അല്ലെങ്കിൽ ഇപ്പോൾ ഒരു മൊബൈലിൽ ഇയാളുടെ സൈഡിലേക്ക് വലിക്കുന്നു തൻ്റെ ബ്രദറോ സിസ്റ്ററോ ആരെങ്കിലും വന്ന് നേരെ ഓപ്പോസിറ്റിലേക്ക് വലിക്കുകയെന്ന് വിചാരിക്കാം ഈക്വൽ ഫോഴ്സിൽ ഈക്വൽ ഫോഴ്സ് അല്ലെങ്കിൽ ഇപ്പം തൻ്റെ ഫോഴ്സ് കൂടുതലാണെങ്കിൽ തൻ്റെ അടുത്തേക്ക് വരും മൊബൈൽ അതേസമയം ഈക്വൽ ഫോഴ്സിലാണ് വലിച്ചിട്ടുണ്ടെങ്കിൽ അതിന് വല്ല മോഷൻ ഉണ്ടാവോ ഉണ്ടാവോ ഈക്വൽ ഫോഴ്സിലാണ് ഇല്ല അല്ലേ അപ്പൊ അതിനാണ് നമ്മൾ ഫോഴ്സ് ഉണ്ട് ഫോഴ്സ് ആക്ട് ചെയ്യുന്നുണ്ട് രണ്ടുപേരും പക്ഷെ പാർട്ടിക്കിൾ ഇക്വിലിബ്രിയത്തിലാണ് നെറ്റ് ഫോഴ്സ് 0 ആണ് മനസ്സിലായോ അതാണ് പറഞ്ഞത് പിന്നെ അതുമാതിരി വേറെ കേസ് പറയാം ഒരു ബുക്ക് ബുക്ക് ഈസ് റെസ്റ്റിംഗ് ഓൺ എ ടേബിൾ വിച്ച് ആർ ദ ടു ഫോഴ്സസ് ആക്ടിങ് ഓൺ ഇറ്റ് വെയിറ്റ് ഓഫ് ദ ബോഡി ഡൗൺവേർഡ്സ് നോർമൽ റിയാക്ഷൻ അപ്വേർഡ്സ് അപ്പൊ ഫോഴ്സ് ആക്ട് ചെയ്യുന്നുണ്ട് അവിടെ പക്ഷെ നെറ്റ് ഫോഴ്സ് ഇസ് 0 അപ്പൊ ബോഡി മേ ബി ഐദർ അറ്റ് റെസ്റ്റ് വേറൊരു കേസ് പോസിബിൾ ആണ് ഇറ്റ് മേ മൂവ് ഇൻ യൂണിഫോം വെലോസിറ്റി ഓൾസോ യൂണിഫോം വെലോസിറ്റി നെറ്റ് ഫോഴ്സ് 0 ഓക്കെ അപ്പൊ നെറ്റ് ഫോഴ്സ് ആക്ട് ചെയ്യുന്നുണ്ട് അവിടെ പക്ഷെ നെറ്റ് ഫോഴ്സ് എടുക്കും വെക്ടർ സം ഓഫ് ദ ഫോഴ്സ് എടുക്കുമ്പോൾ 0 ആയിരിക്കും അതാണ് അതിന്റെ കണ്ടീഷൻ അതാണ് വെക്ടർ സം ഓഫ് ഓൾ ദ ഫോഴ്സ് ഈക്വൽ 0 That is the condition for translational equilibrium. ടോർക്ക് അതുപോലെ തന്നെയാണ് നെറ്റ് ടോർക്ക് ഉണ്ടാവും പക്ഷെ നെറ്റ് ടോർക്ക് ഇപ്പൊ ക്ലോക്ക് വൈസ് ടോർക്കും ആന്റി ക്ലോക്ക് വൈസ് ടോർക്കും ഈക്വൽ ആവും ടോർക്ക് ഉണ്ട് പക്ഷെ ക്ലോക്ക് വൈസ് ടോർക്കും ആന്റി ക്ലോക്ക് വൈസ് ടോർക്കും ഈക്വൽ ആയി കഴിഞ്ഞാൽ അവിടെ നെറ്റ് ടോർക്ക് 0 ആയിരിക്കും അപ്പൊ അതാണ് എക്സാമ്പിൾ Okay, okay. Partial equilibrium എന്താന്ന് നോക്കാം mechanical equilibrium means total torque must be 0, total external force acting on the system also should be 0. And then partial equilibrium, let us see, partial, only one condition will be satisfied in that. Partial equilibrium. A body may be in partial equilibrium, that is, it may be in translational equilibrium and not in rotational equilibrium, or it may be in rotational equilibrium and not in translational equilibrium. Any of two will be satisfied. So here you can see a rod. I will ask question, all of you listen very well. You can see a rod here. AB is a rod scale like that. You can consider a rod AB. It is not fixed anywhere. Just a rod. You are having a scale with you. You think you are having a scale with you, and you are applying a force at the two ends. You are applying a force. Equal force you are applying in the downward direction. Equal force you are applying in the downward direction. Will it have translational motion or rotational motion? That is the question. Very easy question. Here a scale is there with you and you are applying the forces downward direction at the two ends. What type of motion will be there on that scale? Will it be rotational or translational? Very easy question. Who will answer? Tell me. Translation, very good. Translation, very good. Because that will be moved downwards. It will not have any rotational motion. But that is correct. So here you can see, consider a light rod AB as shown in figure. At the two ends A and B of which two parallel forces, both equal in magnitude and acting along the same direction downwards, are applied perpendicular to the rod. We are applying the force perpendicular to the rod. Let C be the midpoint of AB. CA equal to CB. And here, if you consider the torque acting on it, you are finding the torque. How will you find the torque acting? Now we know the net force equal to F plus F, that will be 2F. Net force acting on it will be 2F, and it will be accelerated downwards. There will be net force, there is translatory motion. Net force is not zero. 2F force is acting downward direction, both acting in the same direction. So when you have to add both the forces, F plus F, 2F force will be acting downwards. But if you consider the torque acting on it, torque means force into perpendicular distance from this center. Torque is equal to force into perpendicular distance. So here, you forget about this force. If you apply a force here at this end only, that will move downwards. It will have a torque acting. It will have a tendency to rotate. To forget about this force, only think about this force. We accept a force here downward. What will happen? It will rotate like this. It will come down like this. That means a rotational effect will be there. So that torque is equal to, that is anti-clockwise direction, in this direction. Anti-clockwise direction, the torque is equal to A into F, that is the torque. A into F, that is the torque in the anti-clockwise direction. And next you forget about this torque, and here think that you are exerting a force here in the downward direction. What is the torque acting here? Torque is force into perpendicular distance. What is the force? F. What is the perpendicular distance from this center point? E. So A into F is the clockwise torque. And here these two, A into F, A is same for both. A into F is same here.